So welcome to a 3D graphics tutorial. We're going to be going through and creating a really simple 3D graphics engine. So we're going to be using the SFML library, which will create a window for us and handle inputs from our keyboard and mouse. There'll be a link in the description for how to download and install this. So we're going to start out with some pre-written classes that I've made. One for a vector that will store a point in 3D space, and one for a quaternion that will hold rotations. I'm not going to go through step by step how to make these. Because they're not really important for understanding how 3D graphics work. Again, there'll be stuff in the description for how to copy and paste this into your project. So the first thing we want to do is we want to create a camera class. So if we make a class cam, make it public. So we need to store the position of our camera, and we'll just default that to 0, 0 to the origin. Then we also need to store the orientation, and we're going to do that by storing 3 different vectors. First of all is the forward vector. And we're going to default that, and it'll point in the direction the camera is facing, and we'll default that to the z-axis. And the 2 others we'll need will be an up vector, which will default to the y-axis, and then the third one will be a right vector, which will default to the x-axis. The next thing we need is we're going to need an FOV, which will just represent the field of view, which will start out with start at 60 degrees, and then we'll just convert it to radians, and then finally, we're going to need 2 functions. So the first one is actually going to be an operator overload. So we're going to overload times equals, and it'll take in a parameter that is a quaternion. And the reason we're taking in a quaternion is we want to be able to rotate our camera by a quaternion. And so when we rotate our camera, what we're really rotating is the orientation. So we need to rotate our forward, up, and right vectors by that quaternion. So we're going to say forward equals forward times q, and then we're going to do the same for up and right. Up, and then we'll return this, and that's our first function done. And so we should be able to say, like, C, if we create a camera called cam C, we should then be able to say, like, C times equals get quaternion, and rotate around the y-axis by 50 degrees, and then convert it to radians. And that'll just rotate the camera around the y-axis by 50 degrees. So the next function we need is we'll return a vector of quaternions, and we're going to call it we're going to call it get reverse orientation, and it's going to return a set of quaternions that when you rotate points by them, it'll represent the orientation of the camera. So the reason we want to do this is we want to actually rotate. We want to rotate the camera back to face in the z direction. So if we're facing this way, we want to rotate the camera so it faces in the z-axis. And the reason we want to do that is it'll make the math later on a lot easier. So the steps we need to do this is first we need to take the forward vector and rotate it, get the rotation that is rotating the forward vector onto the z-axis. So we can do that by saying quaternion forward to z is equal to get quaternion between our forward vector and our z-axis. And the next thing we need to do is rotate our up vector, because it could be any direction pointing in any direction away from the z-axis. We need to rotate our up vector to the y-axis. And that is our up vector that's rotated after it's been rotated by our forward to z quaternion. So we'll just copy this, and we'll say up to y will be our up vector rotated by our forward to z quaternion, and get the rotation between that and our y-axis. And then we can return a vector of those 2 rotations, forward to z, up to y. And those are the only 2 functions we actually need for our camera class. So the first thing we should do is, if our camera is active, we want to set our controls. You can toggle the active by pressing the escape key. And so this will just make sure that if we want to, regain control of our mouse while we're debugging, we can just press the escape key. So here, first we'll take care of the movement of the camera. So if our W key is pressed, which are stored by these booleans here, then we're going to want to move forward. So c.position equals c.position plus our forward vector. So we're going to be moving forward, and we're going to scale it by 60. You can choose any value right there. 60 is just a good value. It'll mean we move 1 unit per second. Then we're going to do the same for S, except we're going to be moving backwards. So we're going to subtract to get forward. I'm going to do the same for AD and left and right, and then shift and space for up and down. Okay, so I've added AD, shift and space. So now we have full control over the movement of our camera. So now we need to work on the controlling the rotation of the camera. We're going to do that by using the mouse position. So every frame, we're going to reset the mouse position to the center, and then if we're also going to check the mouse position, and if it's different from the center, then we're going to rotate up if our mouse is up, down if our mouse is down. We'll rotate the camera to the right if it's to the right, and left to the left. So first thing we're going to do is we're going to get the mouse position. To MP is equal to mouse get position, and this is an SFMO function that will do most of the work for us. And then after we rotate the camera, we're gonna oops, that's not what I wanted. After we rotate the camera, we're gonna call map. Oh my gosh, mouse. Oh my, we're gonna call mouse set position. We're gonna do vector to I. We'll do width set its position to the center of the screen, which is width divided by 2 and height divided by 2, and set it relative to the window. And then when we get and then yeah, there we go. Okay. And so in between here, we need to handle the position. So if mp.x is not at the center of the screen, then we'll do some rotation, and then we'll do the same thing for the y if it's not equal to height over 2. So if you remember, we overloaded the times equals for our camera. So we're gonna do c times equals a get quaternion. And so in order to rotate horizontally, which is what we want to do when the x value is not the width over 2, we're going to rotate around our y-axis, which is pointing upwards. So vector 3, 0, 1, 0. We're going to rotate around an axis a certain amount of degrees, and that degrees is going to be the difference between our mp.x and the width of and the center of our screen. And then we should also scale this. So first of all, let's do degrees to radians, and then we'll also do 0.1 times that. And this is just a good way to scale stuff. You can set a variable to this and control it if you wanted. Then we're going to do a similar thing for the y, except instead of being around the y-axis, it's going to be around the camera's right axis. And instead of mp.x, it's going to be mp.y, and we'll use the height. And then we also need to reverse it because the screen coordinates are actually high to low instead of low to high. Yeah. And so that's actually all the code we need for setting our camera position. So now we can get on to drawing our actual triangles, which are stored up here. It's just a bunch of vectors of points. So we'll do for int I is 0, I is less than 12, because there are 12 triangles in our cube, I++, and so we'll say we need to create 3 new points, which represent the rotated points, which will be rotating by the reverse orientation. So actually up here, we'll say vector of quaternions reverse cam is equal to c.get reverse orientation. And so we need to then create 3 points. We'll start one with P, one called P, and then one called Q, and one called R. And so the first point is going to be tries at position 3 times I plus 0. And we first want to move the camera back to the origin. So we'll subtract c.position, and that'll move it to the origin. And then once it's at the origin, we want to rotate it to face the z direction. So we'll multiply by reverse cam at position 0, and then we'll multiply again by reverse cam at position 1. And we can then just pretty much copy this for these, except change the points to be the next ones in the list. And those are our final rotated points. So now we need to talk about how a perspective camera works. So go into our project, and we can go and implement those equations. And so we need to apply them to each point. So we'll change, so p.x is going to equal to our width divided by 2 times p.x divided by p.z times the tangent of c.fov, because remember theta is our FOV, c.fov divided by 2. And then the y component for p is going to be our height divided by 2 times p.y divided by p.z times the tan of c times FOV over 2. But then we're going to also have to multiply by h over w. And then let's make sure this is an integer division. And so then we can just copy and paste this for Q and R. Okay, so now that we have Q and R finished, we can finally draw our shapes to the screen. So we can create a convex shape, which is an SFMO class that takes a number of points as parameters. We're going to give it 3 because it's a triangle. We'll name it shape. And we're going to do shape.setPoint. We'll set the first point to p.x, or sorry, vector 2f p.x and p.y. But then we also want to make sure that it's centered on the screen. So let's do W over 2 plus that, and then height over 2 plus that. That'll make sure they're at the center of the screen. And then we need to do the same for Q and R, so I'll go ahead and do those. So I've done the same for Q and R, and so now we need to set fill color. Set fill color, calls at position I, and now we can tell the window to draw our shape. So window.draw shape. So now if we run it, at first, so you can see we're seeing something here and nothing is moving. That's because we aren't active. We have to press escape, and then we have control of our camera. So you can see we appear to be drawing a cube somewhat correctly, but there is one problem. See, these triangles down here are being drawn on top of the triangles that we should be seeing. And so the way we're going to fix that is we're going to get which direction these triangles are facing, and if they're facing away from the camera, we're not going to draw them. And the way we're going to do that is we're going to create a new vector 3 called normal, and we're going to set it equal to the cross product of q minus p and r minus p. And so this will basically be pointing in the direction the triangle is facing. And so then if we're going to say if, then we will only draw the triangle if the z component of our normal is less than 0, which means it's pointing towards the origin. And since we're facing away from the origin, that means it's facing towards us. Yeah, so then if we run this, you can see we don't see anything, and the reason for that is we're inside the cube right now, so all the triangles are facing away from the others. So if we press escape, then move around, so you can see we're correctly drawing our cube. And that is how to do 3D graphics at the most basic level. Yeah, thanks for watching.